Hey, welcome everybody into the Wells Tech Garage. Thanks for joining me today. As the title suggests, guys, I want to share with you what I think to be the quickest and most efficient way to diagnose a standard GM EVAP purge seal system. Sitting here in front of me is a 2004 Chevy Cavalier with a 2.2-liter Ecotec motor under the hood. Now this thing has a check engine light, and this procedure that I'm going to detail out today will require a scan tool with full bidirectional controls. All right, as we get into this, I'm going to go ahead and we're going to look at codes first because we've got to figure out exactly what's going on and what the PCM is recording. And we're showing a P0455 large leak code. So very common, could be a lot of different things. Now a leak code doesn't necessarily always mean there's a leak. There's really one of three options that could be setting a leak code. One, and most obvious, is an actual leak. Two, there could be a problem with the fuel tank pressure sensor not representing or sending the right voltage signals back to the PCM, or maybe misinterpreting that, or the PCM misinterpreting that. And three, there could be an issue with the vacuum being applied to the fuel tank system. The system uses vacuum to test. It opens up the purge solenoid and draws the entire system into vacuum. If there's an issue with that vacuum getting into the tank from the purge solenoid, like a blockage or a bad purge, it would also set a large leak code, or maybe a small leak code, depending on the problem. So we need a way to determine, as a technician, while we're sitting in the seat of the car, where we're going next. Are we popping the hood? Are we looking at the filler neck and the gas cap? Are we inspecting the vent solenoid? Or are we looking for a hole in a line somewhere? We have to have some sort of idea so that we're not wasting time. We want to remain very efficient. So as we're sitting in the car, we just pulled codes. We're 30 seconds into this car. Let's go into functional tests, and let's take a look at one of my favorite tests for EVAP, and that is the EVAP purge seal. What this is going to do, this is going to allow us to control the purge solenoid, shut the vent solenoid, and monitor fuel tank pressure. So I'm going to go ahead and grab a custom graph. I'm going to get rid of all this other stuff because all I really care about here are these four PIDs. So we got up on the screen our vent solenoid, is it open or closed? Our fuel tank pressure, what it is in inches of water. Then we have our purge solenoid, percentage of how far it's open, and then we also have our fuel tank pressure sensor written in voltage. Now this test does require the vehicle to be running, and what we're going to do is we're going to open up the purge, we're going to shut the vent, and we should see almost immediately a vacuum building up inside of our tank, right? We have the intake manifold vacuum being applied to a sealed system. It should very quickly drop down in vacuum. All right, we'll let our idle stabilize here for just a second. And you can see our fuel tank pressure sensor right now is sitting at 1.5 volts. That is going to be atmospheric voltage. That is going to be the system vented. 1.5 is a known good voltage on a GM vehicle. So as soon as I push this green purge button up here, we're going to shut the vent. All right, you saw our vent graph here go from open to closed. And our fuel tank pressure sensor is still sitting at 1.5, which I would expect at this point because we have not yet started to draw a vacuum. We haven't opened up the purge. At 10%, we should begin to build or draw vacuum on this system. Nothing. Let's start ramping this up. We're getting a little bit now, but still not what I was expecting. Negative 1 point something, 1.7 volts. I mean, we're not looking at a ton of vacuum in here. Let's keep going. We have this thing 100% open. We should be up over into the double digits of vacuum. This thing should have canceled the test out at this point. It should be drawing more vacuum. So what's happening here? Let's click this X for seal. What this is going to do is it's going to shut our purge off instantly. There we go. Our purge went from 100% down to 0, and our fuel tank pressure sensor responded just as quickly back to that 1.5 volt mark. What does this tell us? Well, we just picked up a ton of information out of here. One, it tells us our purge solenoid is able to be opened. We were able to draw vacuum on our system to the point where the vacuum being built by the engine drawing on the EVAP system was able to overcome the leak that was happening, so we were able to draw a slight vacuum. It told us another thing. It told us our fuel tank pressure sensor is able to respond somewhat. It's able to do something and show us that we have vacuum in our tank. And three, one thing, and I don't know if you guys heard it or not, or didn't hear it, I never heard a click when the vent solenoid turned on. Now GMs, especially old Cavaliers like this, you would hear an audible clicking sound when that vent turned on. And just to verify, let's go into vent control quick. I'm just going to grab the vent solenoid on off. And I'm going to cycle that thing a couple times and see if I can get it to turn on. I got nothing. I hear no clicking whatsoever. So by you're 4 minutes into the job right now, you just ran a purge seal. Now I'm putting this car up on the hoist. It's time to take a peek at the vent solenoid. Either I have a bad power wire to the vent, a bad control wire from the PCM to the vent, or a bad vent solenoid. So we got to confirm that and then retest. So let's get this vehicle up in the air and take a look. Hang on. Okay, so we're under the vehicle on the right rear. You can see the right rear tire there. We got our canister in the middle. And as we zoom in here, guys, this is where our vent solenoid is located on here. Pretty much mounts right into the frame. Pretty easy access on this. Really not too bad to get to mounting right here. So we knew that this thing wasn't clicking. Let's just listen one more time as we turn it on and off for any clicking. On, off, on, off. We got nothing. So we either have a problem with the wiring and the power and ground coming to this thing, or we got a bad solenoid itself. So why don't we go ahead and pop the connector out of the backside here. And just with a simple incandescent test light, we're going to be able to test this circuit, because really this power and ground is a consistent power, usually from a fuse, and then the ground is ground side controlled by the PCM. So we're going to take a test light here, and we're just going to put a small load in the circuit. Test light's about 1/4 amp or so, and we're going to see if we can get this guy to light up. If we have proper function here, we're all set to go. So we'll go ahead and turn this thing on and off, on, off, on, off. All right, so really this just confirmed our power and our ground back to this thing. It's time to throw the new one on. So we got a new vent solenoid here, as you can see, nice and shiny clean. And let's go ahead and plug it in and see if we can get this one to click, because that's kind of what these GMs are known for. They're known to click when they open and close. Let's go ahead, on, off, on, off. All right, huge difference. I can actually feel the solenoid inside of here moving as I turn it on and off. And just a couple more times, on and off, on, off. We got a good clicking solenoid, so really it's just swap this hose over to the new one, put this one up into the frame rail. I'm going to finish this up right now. Why don't I'll catch you guys on the top side of the car where we verify the repair. All right, so with the vehicle back on the ground now, the new vent solenoid installed, I just want to go through a really quick verification process, basically just doing the same test again. So back into EVAP purge seal, and we're going to go ahead and load it up here. And while that's loading, let's go ahead and fire up the car. Alrighty, and let's get our custom graph back, get rid of all this stuff. Alright. And now everything should look the same, 1.5 volts on our fuel tank pressure sensor, vent solenoid open. I'm going to go ahead, click purge. I closed the vent, and I heard it that time. I could audibly hear the vent open. And look at that, we're already gaining pressure inside of the tank. That means because our hot exhaust is actually going past the tank, it is slightly increasing the pressure in there. Let's go ahead and bump this up to 10%. All right, so with our purge at 10%, we can already see our voltage coming back up in voltage and our tank pressure coming back down. Let's up it a little bit more. And you can tell we're already significantly lower or higher in vacuum and higher in voltage than we were before at just 20%. So I'm going to press the X up here to seal the system. Now we shut our purge solenoid off. Our vent solenoid is still closed. And look at our fuel tank pressure. It will slowly bleed up. There's not a perfect sealed system. Remember, it has to go for a set amount of time at a set level of vacuum. All right, we did not instantly decay our vacuum like we were before. Okay, so now depending on, I'm gonna go ahead and shut this car back off. Now depending on the vehicle, the temperature, the fuel level in the tank, we'll change those parameters on how long it takes for this thing to decay the vacuum back up to its passing or non-passing rate. But right now we have a noticeable change in this system. It's time to go out and run the drive cycle, clear the codes, run the drive cycle, and get the car back to the customer. So that's going to be what I think to be the quickest and easiest way to verify and test the EVAP system. So let me know what you guys think in the comments below. If you liked what you saw, please give us a thumbs up. Please subscribe if you haven't already, and make sure to check us out on social media, out on Facebook, LinkedIn, Instagram, and Twitter. We're all there on all of those. Search for Wells Vehicle Electronics or follow the links in the description of the video. So thanks again for watching, guys, and we'll see you again next time. Happy wrenching, everyone. Thank you.